Hello everyone, today I will introduce how Apache Pulsar helps Tencent process tens of billions of transactions efficiently. Tencent Midas is an internet billing platform. It carries 100 billion level revenue of Tencent's internal business. It integrates domestic and international payment channels and provides various services such as account management, precision marketing, risk control, auditing, accounting, billing analysis, and so on. The platform carries daily revenue 100 million of dollars. It provides services for more than 180 countries, more than 10,000 businesses, and more than 1 million settlers, working as an all-round one-stop billing platform. The total number of accounts is over 30 billion. This figure is Midas Architecture. This figure shows the whole framework of Tencent Midas as a billing middleware. On the top is our business interface, and then our billing service layer, billing system layer. TDXA and TDMQ is in a core technology layer here. We'll talk about them in details later. In such a huge billing scenario, there are several pain points. The biggest one is to ensure the consistency of payments and goods delivery. Usually, we may face failures and timeouts of system. A single payment of Midas often involves many internal and external systems. This makes longer call chains and more exceptions, especially in network timeouts, DB errors, goods delivery failures. It also requires high data reliability when database deployed in different regions. We may also solve the problems of subscription and recurrent payments. Also need to solve in-time account reconciliation. It also requires our system can be automatically scaled elastically according to the business scope. Midas has developed its own distributed transaction engine, which called TDXA, to solve these problems. TDXA is a framework solution for transaction control. It is used to solve the consistency of transaction logics. The architecture of TDXA is as follows. In the middle, TM, which is a distributed transaction manager, and the control center of TDXA. It adopts the decentralized mode to provide services of high availability. TM supports both REST API based on TCC and hybrid DB transactions. With the help of the coroutine asynchronous framework TDF and TD-SQL, TM supports the billing business of the whole company with high efficiency. To the left side, CM, which is the configuration center of TDXA. CM introduces flexible registration mechanism. CM introduces flexible registration mechanism with jump control interfaces and designs e-graphs for transaction process in real time. It automatically checks the correctness and completeness of the process. and displays the process to users in graphical interface, which called GUI. Users can manage the process in GUI. To the right side, TD-SQL, which is a distributed financial database. It has the characteristics of strong consistency, high availability, global deployment architecture, distributed horizontal scalability, high performance, enterprise-level security, and so on. TD-SQL provides comprehensive solution for distributed database. TDMQ enables TDXA to deal with messaging with high consistency and availability, and makes convergence of various exceptions with the state table. This figure shows the deployment of Tencent Global Billing System. It's deployed in Shenzhen and Shanghai of China, while in Hong Kong and Singapore overseas. As we just said, MQ enables TDXA to deal with messaging with high consistency and availability. There are three main points of MQ. First, a synchronized data transmission between systems, such as the communications between transaction engines and channels. Second, system exception handling. With timeouts and exceptions occurs, TDXA will make current transaction status retrievable automatically. The status is written into MQ, and MQ will continue the transaction and ensure the consistency. Third, the strong consistent synchronization of data. Currently, the billing systems are deployed in multiple locations. Thus, the logs of the lower database needs to be copied across cities. The high availability of data is ensured by MQ. It is required that even if the network in a certain area is completely interrupted, the data is consistent, reliable, and effective. In general, Tencent Billing requires MQ to be highly consistency and high availability across regions. Massive storage, which means able to manage massive delayed messages and massive topics. Highly concurrent consumptions. Highly scalability. Support message modification and more protocols, such as RESTful and AMQP protocols. Pulsar perfectly supports the first 4 points. That's why we choose Pulsar to be our infrastructure. For Geo Replication, we apply 2 solutions of Pulsar. For the cross-city one, we apply high consistency of data replication because of its stable time consumption, 30 to 100 ms. For the cross-region replication, due to the stability reason and the time consumption is over 100 ms, we deploy 2 clusters using asynchronized data transmissions. The performance test is as follows. 3 replicas in the same city up to 360,000 QPS, while 3 replicas between Shenzhen and Shanghai, stable to 280,000 QPS, 20% reduction, but meet the requirement. Kafka focused on scale and high throughput. Its async transmission is up to 1 million QPS, 2 times of Pulsar. But when it's on sync model, only 60,000 QPS. Therefore, Kafka is not suitable for billing scenarios. Practice of DB replication across cities. For our TD-SQL database, based on bin log and hash method, we separate the system logs into message queues. Therefore, we can take advantage of machines and bandwidth resources to achieve concurrent replication. In the meanwhile, message batch compression enables us to further make use of internet bandwidth to improve efficiency. Many tests shows MQ's bottleneck is bandwidth. Finally, using hash methods will lead to out-of-order data flows. When the bin log is executed on the other database, we need to do conflict detection to fix the order and ensure correctness of data. In practical, the data replication rate can reach 100,000 RPS when copying from Shenzhen to Shanghai, with a delay of about 30 ms. Basically, it is equal to the delay of the network itself. The first question is about performance. The first question we need to point out is failure performance. Since the default production and consumption can only be worked on the leader broker, meanwhile, in the cross-region conditions, consumption can only be carried out in different places, which leading to a relatively higher delay and lower performance. To solve this problem, we proposed a read-only broker, that is, to use other brokers as reading nodes, which can highly improve the system's ability to process concurrency and reduce the consumption time without reducing consistency. A key issue here is to synchronize the status of leader broker in time. The consumption may be slow due to the lack of synchronization. The solution is that if the read-only consumption is not available, consuming at the leader broker again. Here, the consumer may need to actively synchronize the message offset. Can we use MQ as an RPC? We can say yes to this question when we add the request reply mode. There are a large number of RPC calls in transactions where you will encounter performance mismatch, authorization or isolation, and inconstant applications. These problems can be solved when RPC can be completed through MQ. Our approach is to add a function to have MQ supported the request reply mode. When the caller produces, they will receive not only the return code, but also the specific response data of the consumer. Therefore, the caller can get all the resources by calling MQ. As an intermediary, MQ will solve authorization and other issues. For the request reply mode, the actual calling serves as the consumer. When the message is confirmed, the return data need to be attached to the response. Of course, the consumer can also reproduce a new message instead of attaching the data. Inside the broker, there are some internal subdivided queues distinguished by session. Actually, it is to put a specific tag in the header of messages, so that different colors can be distinguished and data can be returned to the original color. For read-only brokers, since they actually cannot produce, they will provide support to forward messages, reducing the time consumption. Generally, networks between brokers are better. How to modify data when data errors happen. A problem often happens in a batch process, such as transaction reconciliation process, is how to correct the small data incorrectness. The reason for not reproduction might be that the amount of data is too large, so that reproduct time will be too long. Here are some specific methods. 1. Offset shadow. After match the message offset through the content, set this interval unreadable. 2. Priority. The revised date can be reproduced, but we need to avoid the queue to be too long to avoid the high delay of the consumption on the tail. We can put it in a queue with a higher priority. In this way, the queue can be quickly modified and quickly consumed again. In reality, to support more languages such as PHP or Node, we need to be compatible with multiple calling protocols, especially RESTful and AMQP. Our approach is to add a proxy layer to support RESTful and AMQP protocol. The implementation of proxy, like Pulsar broker, is still a question of how to keep the consumption balance of proxy. Fortunately, Pulsar has SDK assistance, which can easily achieve a balance of access. But for the proxy, you need to consider the possibility that data is unable to be consumed when the access is imbalanced. That is, a proxy pulls a batch of messages, but the consumer consumes only part of the message. As a result, the cached messages of the proxy is invisible. The specific strategy is to control the message cache period and return them in time, which is put in the retry queue. In one word, TDMQ based on Pulsar is widely used in Tencent Midas platform. Efficiently supports Tencent business development. Our further development, such as read-only broker, has been committed to the community. Will continuously contribute to Pulsar community. We look forward to work together with you guys and fulfill more business and tech scenarios. Thanks.